Next now, we're going to look at the list that are available in the Java library. As I mentioned at the beginning of the course, our concern in this course is really to understand these data structures and their efficiencies. And the only way we can understand the efficiency of a data structure is by examining how it is actually implemented. Okay, so we have done that for singly and doubly linked lists. What we are going to tell you now is that actually in the Java library there is already a linked list there, and there's also something called ArrayList. I'm sure you have seen them in your programming 2 course. So what we're going to do now is just to discuss and see what method they have. The idea is if you are writing a real project, maybe after you might have graduated or maybe during your final year project, do you have to use the doubly linked list that we have just developed? The answer is no. There is a doubly linked list already in the Java library. You can use it instead of using your own. The idea of learning or developing your own is to actually know how doubly linked lists behave, so that you can determine whether it is good enough for you in your project. So now that we have seen how it is implemented, let us now look at the one already in the Java library. This is the one that you are most likely going to use in your projects, not necessarily the list that we have developed. Okay, so in the Java library there are a number of data structures. Among them are 2 lists. One of them is linked list. Now, when I say Java library, it means the class is in some package in the Java library, and that package actually is java.util. So before you can access this linked list, you have to actually import that package. You have to say import java.util. Its implementation actually is very similar to the method, to the doubly linked list that we have developed. It is a doubly linked list, even though it is simply called linked list. It is actually a doubly linked list, and it is a generic class. I'm sure you already saw it in programming 2 course, and therefore you can use it to store any type of data. Now, once you create an instance of this linked list, it behaves exactly like our doubly linked list. Okay, it has head and tail, and each node will have info, next, and prev. Although you don't need to actually access these variables directly in your code, you can just call the methods of the list. But the class behaves very much similar to our own doubly linked list that we have developed. Now I'm going to show you some of the methods of the class. If you want to see all the methods, just go to the documentation of the class. You can go to any browser and type doubly linked list Java, and you will see the documentation. It will show you all the methods in the class. But here I'm going to show you just the most important methods. Okay, so let us go through the methods of the linked list in the Java library. First, let's look at the add methods, the method that allow you to add a new node to the list. Okay, we have a number of them. We have add, which takes an object, add, which takes an index and an object, and then of course we have add first and add last. So what do this method do? Here, if you notice this add, it didn't say where it's going to add. It just take an object and it will add it to the list. The question is, where is it going to add it? Actually, it's going to add it at the end of the list, because actually it's thinking of a list like a some kind of queue. we will come to learn about queue later. In queue, normally when you are adding a new element, you will put it at the end. This is the natural way. The first come, first serve. So the last guy that come should go to the end. But when you are removing, you should remove at the beginning, because that is where you will find the first guy that joined the queue. Okay, so that's how you should think about this add. If you just say add, naturally, where are you going to add to a list? You will add at the end. Okay, so this is what this method will do. But notice the return type. The return type for add is not void, it is Boolean. Basically, it's going to tell you whether the addition is successful or not. Usually, the addition will be successful, so this is almost always going to be true. Because the only way the addition will not be successful is if the computer ran out of memory. Okay, then you cannot create a new node, so this method may return false. But generally, this is always true. Okay, the second method is more interesting actually, and it is the type of method that we're going to ask you to do for our DLL, I think in the lab, because it is giving you an index and then an object to add. So it's saying add this object at this location. So this could be any valid index within the list. For example, if the list currently has 5 elements, if you say add at 2, then you're going to make an insertion between the second and the third element. Okay, no, actually it's the third, because the counting is from 0. So we'll have number 0, number 1, and then the one you're gonna the new one that you're gonna add will be the new number 2. Okay, so if this index is 2, this is what will happen. I will show you how this method works with a real example in the lab. Okay, so that is the second add method. The last two methods are exactly like our add to head and add to tail. The only difference is the name. Here they call it add first and add last. Okay, so here it says add first will insert an object at the beginning of the list, whereas add last will insert an object at the end of the list. Same like the add here, because we say this add will add at the end. So add last and add are exactly the same, only that one is void, one is Boolean. Okay, so those are the add methods. We have clear method, exactly like our clear method in the DLL class. It will remove all the objects from the list. It will clear the list or empty the list. Okay, then there is contains method, which is Boolean. Now this actually is not as useful as our find method, because this only tells you whether this given object is in the list or not. It doesn't return the content of the list. Okay, if you want to get the content, you have to use another method which we shall see in the next slide, which is called get. Okay, so this contains is a Boolean method. Simply return true if the list contains the given element, or false otherwise. Actually, the get method is here. The get, you will give it a position, and then it will return to you the element at that position. So again, this is not as good as our find method, because you see the get requires you to give an index. Okay, so in fact, to have the equivalent of our find in the Java's linked list, we need to call two different methods. First, we have to call this index of method. Okay, so the index of will take an object and return to you its index in the list. So now once you have the index, now you can call the get providing it that index, and then it will return to you the element. In our find method, we combine these two into one. And actually ours is more efficient, because imagine, for example, you have a list of 1,000 nodes and you are trying to get the one at 999 position. So this index of will have to traverse the loop. We'll have to traverse the list almost completely before it can get you the index. And then this get method cannot give you the element directly, because it's not an array, it is a linked list. So it has to traverse the list again, almost 1,000 times before it gets you the element. So this is one of the disadvantages actually in this Java's linked list. The get method is not efficient, because before you can call it, you have to call the index of. So that means two traversals instead of only one. Okay. But the get first and the get last, I think their meaning is obvious. It will simply return to you the info in the first node, and this one will return the info in the last node. It's empty is also obvious. Just tell you whether the list is empty or not. Okay, what about the deletion methods? So like the add, there are several deletion methods. There is remove, which has no parameter. There is a remove with an object. There is a remove with an index. And then there is remove first and remove last. As you will guess, these last two are the one equivalent to our delete from head and delete from tail. This is equivalent to actually our general delete. If you recall, we give it an element. It will try to locate the node containing that element, and it will delete it. The only difference is this one, instead of returning the info in the node that is deleted, it's returning true or false. True if the element was found and deleted, or false otherwise. This is what we are saying here. Remove the first occurrence of object in the linked list, and return true if object was in fact in the linked list. Otherwise, it will return false. Now, this is similar to the add method that we saw in the last slide, where if you say just remove, what do you mean? Without indicating where to remove and without giving any parameter, no argument here. So the same logic that we said for the add, if you just say add, the idea is add at the end. If you say just remove, you mean remove at the beginning. Okay, so this is what this remove will do. Say remove and return the first element in the list. Okay, so those are the remove. Of course, there is this one which we're going to ask you to do something similar in the lab, to remove the node at a given index. Okay, so it will go through the list until it reaches this index, then it will delete. Of course, it will return it will raise an exception, index out of bound, if you give it an index that is not valid. If, for example, there are only 10 nodes in the list, and you say delete or remove number 20, obviously there is no number 20, so it's going to return an exception. So those are the remove methods. And then we have set. Set is like replace. So it's going to take two variables or two arguments, the index and the new value. So basically you are saying replace the info in the node corresponding to this position with this new information. Okay, so assign object OB to position pause and return the object that occupied this position before the assignment. As you can see, the method is not void actually, so it's going to return the original value that you are replacing. Yeah, like the other method with the index, if the index is not valid, of course it will raise an index out of bound exception. And then we have the size. Size basically is telling you how many nodes are in the list. Okay, return the number of objects in the list. And then finally we have toArray and toString. So toArray says convert the list into an array. So you have a linked list, but you want to generate an array from it. All the elements in the list will be put in an array and returned to you. Okay, we're going to do similar method in the lab. And the final one is toString. Okay, we want all the info inside the list to be combined together in a single string and return. For example, maybe we want to print all the elements with just one call. So just call the toString to get the information as one string and print it. So these are some of the important methods in the Java's linked list class. And as I said, we're going to see how some of them are used in a program in the lab. This slide actually shows a sample of the program that we're going to examine in the lab, but I will not waste time showing you the program here because we're going to test run it in the lab so that we can understand how to call those methods more clearly. The other data structure, which is in the form of list in the Java library, is the ArrayList. ArrayList is similar to linked list, but actually it is implemented as an array. So that means it has the good and the bad things about an array. If you recall, the good thing about a normal array is that it allows you direct access to its elements. The bad is that it has issue with size. Okay, because an array, to create it, we have to give a size. Whether we give it or the Java system will give it in this case, either way a size has to be specified. And that size may be too big or it may be too small. If it is too big, we are wasting memory. If it is too small, the program is not going to break in this case, because what will happen is Java will create a new bigger one and then copy the data from the old small one to the new one. Okay, so the Java system takes care of handling the size. But as you can see, even though the program will not crash, it is not going to be efficient either, because this time that is spent copying data regularly from a smaller array to the bigger one will definitely take some time. So this is the advantage and disadvantage comparing ArrayList and linked list. But in terms of the methods, they are very similar. Apart from this, actually there's another class called vector in the same java.util, which is similar, which is also like an array. Okay, with similar set of methods. The only difference between ArrayList and vector is that one of them is synchronized and the other one is not. What does synchronize means? Say ArrayList is equivalent to the class vector, except that the methods in the vector class are synchronized. Synchronized means only one method operates on the list at a time. The idea is you could have more than one processes trying to access your data structure at a time. And that could lead to a problem because one process may delete an element, okay, while another process is trying to get the count, how many elements are there. So the answer of count is going to be depending on which of this method was called first. Because if the count is executed before the deletion, and then the value is returned to that process, and then the other process delete one more node, then you're going to have a problem. Because that process is expecting, for example, there are 10 elements. Well, in fact, now there are only 9. Okay, so this is usually a problem that is solved with what is called synchronization. Now, ArrayList automatically allows synchronization. Sorry, vector class allows synchronization automatically. It doesn't allow two processes to access the same object in parallel. It will make one process to wait until one finish before another one can access it. So in that way there will be no problem. But if you allow two processes or more to operate on a data structure, there could be a problem. But this is an issue for a more advanced class. Maybe you don't have to worry about this issue for now. For now, think of ArrayList and vector as more or less the same, because they have more or less the same methods. Okay, and they are flexible arrays, meaning once they are exhausted, the Java system automatically recreate a bigger one and copy the data to the bigger one, so the user doesn't see any issue in terms of crashing the program. Now these are some of the methods. They are very similar to the methods in linked list. We have add and add at index. Notice, however, here there is no add first and there is no add last. Okay, this is one point to observe. We're gonna see this issue when we come to use this array list to implement, I think, stack or queues later in the next lecture. There is no add first, there is no add last, but there is add, which like linked list will add at the end. Add will add at the end. Or if you give a position, it will add at that position. Okay, clear is there, contains is there. Now this is a new method. We didn't see this in linked list because there is no need for it in linked list. Ensure capacity. Okay, the idea is, as we said, when you create an array list, the Java will give a default size, usually 10. Okay, so when it realizes that you're going to add more than 10, then it will double it. It will be now size 20. Again, by the time you try to insert element number 21, it will double it. So you have an array of size 40 and so on. Meanwhile, it is wasting time copying data from the smaller array to the bigger array. So if you want to avoid this problem of wasting time, and you know that your data is going to be 100, you can immediately after you create your array, before you even start adding elements, you can call this method. Ensure capacity, and you give 100, for example, as your limit. So immediately it will make the array list to be of size 100 without waiting for it to be finished and then doubled again when it finished and so on. So right away make it to be of this size. This is what this method is going to do. So if you can observe, this will actually make it more efficient, especially if you know you're going to store many data elements. When you create an array, you actually have two options. Either you put the value, the size in the constructor, because the array list, the constructor can also accept the size as a parameter. But in case you don't do that, you can also call the ensure capacity. Okay, so it says if necessary, it will increase the capacity of the array list to accommodate at least the value that you provided here, cap. Okay. Then we have get index of is empty, exactly like we saw in linked list, no change here. Okay. And in terms of remove, again, there is no remove first and remove last. We only have remove a given object or remove at a given position. Okay, so this is again another thing to observe, comparing ArrayList with linked list. But there is a set method, behaves exactly like the one in linked list. There is the size, which will return how many nodes or how many elements, and you have two array. And here is another important method that is special for ArrayList. Trim to size. Trim to size is a very useful method. The idea is, suppose for example, when you are creating the array list, because you don't want it to be wasting time doubling the array each time it is exhausted, you know you're going to store 1000 elements. So you provided the 1000 either in the constructor or by calling the ensure capacity method. So an array of 1000 elements has been created. But then you realize after entering the data that actually it is not up to 1000, it's only like 400. Okay, so how do you return the remaining cells back to the system? Is there a way to do that? Well, there is. This is what this method will do. It's a trim to size. Trim the capacity of this array to the size given. I mean, to its current size. Yani, all the empty cells are going to be like deleted. Of course, as we know, array cannot be deleted. What will happen is actually it's going to create an array of the size exactly like the content of the current bigger array. Okay, it's an array of size 100. That's the capacity. I mean, 1000. That's the capacity. But actually, it contains only 400 elements. So that is the actual size. The rest are empty cells. So it will create an array of size 400 and then copy the data from that big array to the new one. Okay, so trim to size will not allow data to be deleted, of course. It will just trim it to make sure no empty cells are allowed. Okay, this is the idea of this method. So all this method, the trim to size and also the ensure capacity, are trying to make sure there is no waste of storage. Okay, so it's trying to save memory. The last method here is the toString. So these are some of the methods. Again, we have an example program showing how some of these methods are called. I will not waste time showing you these methods here. We will run them live as part of the lab, and you will see how they actually work. Okay, so this is basically the end of this lecture. In the lab, we will first practice our DLL, and just make sure we understand all the methods and be able to add more methods. And then we will also study this list data in the Java library, make sure we understand how the methods actually work. This is the end of the class. Thank you very much.